Hello everyone, my name is Nathan Marcellus and I'm from the OTHM batch 13. Today we'll be talking about identification of the internal components of a computer. We'll be talking about the central processing unit, the function of a CPU, how the CPU components work together, the storage media, how data is represented in a computer system, how encryption can be used to represent data, how images and sound are represented in a computer system, how compression can aid the storage of data, images, or sound, the purpose of logic gate, the purpose of different types of computer networks, the hardware, the software, and the transmission media using computer networks, identification of a range of World Wide Web technologies, the purpose of different types of computer network topology. This is the parts of a computer. The computer is an advanced electronic device that takes raw data as input from the user of process these data under the control of set of instruction called program and gives the results output and saves output for the future use. A computer is a combination of hardware and software resources which integrate together and provides various functionalities to the user. Hardware and the physically components of a computer like the processor, memory, devices, monitor, keyboard. While software is the set of programs or instructions that are required by the hardware resources to perform various operations as per the requirement of the user. The central processing unit. Babbage Mill in his difference engine finds its modern counterparts in the CPU of today's computers. The term central processing unit harks back to the early days of computing, when all the security required to enter a machine level instructions and perform operations on the input data was housed within a single massive cabinet. Back then, the CPU handled all processing, including that peripherals like printers, card readers, and early storage devices such as drum and disk drives. Today, however, many peripherals devices come equipped with their own powerful processors, capable of handling a significant portion of their tasks independently. This offload of outputs operation frees the CPU of concentrate on the core computation task, enhancing overall system efficiency. This is what a processing unit looks like. The function of a CPU. The function of a CPU, the central processing unit or CPU, acts as the brain of a computer. Its main job is to process instruction from programs and perform calculations to carry out tasks. Whether it's running an app, playing a video, or simply moving your mouse, the CPU makes it all happen by quickly interpreting commands and managing data. It works in tandem with other parts of the system, like memory and storage, ensuring everything runs smoothly and efficiently. Essentially, it keeps your computer thinking and responding to whatever you need it to do. The function of a CPU. The CPU or central processing unit is basically the brain of your computer. Its main role is to process instruction and handle calculation to get things done. Whether you're launching an app, streaming a video, or just moving your mouse around, the CPU is the one making it all happen by quickly processing commands and managing data. It works closely with other components like memory, storage to keep everything running smoothly. In short, it's what keeps your computer responsive and ready to tackle whatever you throw at it. How the CPU components work together. Here's a simplified diagram of a fictional CPU to help you better understand its key parts. You'll notice that components like RAM and the system clock are shaded there. They are not actually parts of the CPU, but are included here for clarity. Also, you won't see any direct connection between the CPU components and the clock in the control unit. The important thing to know is that every part of the CPU relies on the signals from the control unit and the clock to work in sync. Cache. The CPU never accesses RAM directly. Instead, modern CPUs use one or more layers of cache that bridge the speed gap. The CPU processes data much faster than RAM can supply it. No cache memory, which is built right into the processor, steps in to help because it's closer to the CPU. Cache is much faster than RAM. It stores frequently used data in instruction, including program instruction. So the CPU doesn't have to wait for the RAM to fetch them. Whenever the CPU needs something, the cache checks if it's already stored there, speeding up the whole process. The arithmetic logic unit. The arithmetic logic unit, or ALU, is the part of a computer that handles math and logic operation. It works with small, fast storage areas called registers, one for each input, A and B, and another called the accumulator for the result. The instruction for a ALU came from a special registration called the instruction register. Here's how it works. Imagine you want to add two numbers. One number goes into the A register, the other into the B register. The ALU performs the addition and stores the results in an accumulator for logical operations. The comparing two values. The data is loaded into the input registers. The ALU then checks the values and outputs either a 1 or 0 to the accumulator, depending on the results of the comparison. Random access memory, or known as RAM. RAM, or random access memory, is a computer short-term memory. It temporarily holds data and instructions your system needs to run tasks. When you open a web browser, play a game, or work on a document, the information for those activities is loaded into RAM so the CPU can access it quickly. This helps your computer run smoothly and efficiently without constantly pulling data from slower storage like a hard drive or SSD. However, RAM is only temporary. Once you turn off your computer, everything in it is erased. How these all units work together. The CPU works in a rhythmic cycle, guided by the CPU clock and managed by the control unit. This cycle is called the instruction cycle, and it involves several steps: fetch, decode, and execute. First, the CPU fetches the instruction, which is stored in the instruction register. This instruction can include fixed data or reference to data that might change. Next, the CPU decodes the instruction, breaking it down into meaningful data, which is then loaded into the A and B registers. These registers are used to perform the task at hand, and the result is stored in the accumulator. Once the task is completed, the CPU moves on to the next instruction by updating the instruction pointer and repeating the cycle. Storage media. Storage media. Storage media refers to physical devices or components used to store data. Whether it's for the long term or just temporary, there are many types of storage media, each with its own strength, limitations, and best use cases. Some are great for quick access, while others designed to keep your data safe for years. Storage media can be broken down into two parts: primary memory and secondary memory. Primary memory or main memory is like your computer short-term memory. It stores the data and instruction that the CPU is actively using while the computer is running. This includes RAM, or most knownly as random access memory, which holds everything the CPU is working on right now, and the cache memory, which keeps the most frequently used data close by the quick access. Unlike long-term storage like hard drives or SSDs, primary memory is super fast but only lasts while the computer is on. Once you shut it down, everything is erased. It's circular for helping the computer work quickly and smoothly. Primary memory breaks down into two parts: random access memory, or called RAM, or read-only memory, which is called ROM. Random access memory is like your computer short-term memory. It temporarily holds data or the things you actively working on, whether it's an app, a document, or even your web browser, so the CPU can access and process them quickly. RAM is super fast, which helps everything run smoothly without delays. But once you turn off your computer, everything in RAM is wiped out. It's crucial for performance while the system is on, but it doesn't store anything long term like your hard drives or SSD does. Secondary memory. Secondary memory is where your computer keeps data for the long haul. Even when it's turned off, think of it as your computer storage space. Example, including hard drives, HDDs, solid state drive, SSDs, USB flash drives, and even optical discs like DVDs. It offers much more space than your computer short-term memory, but it's slower to access. While RAM handles tasks you're working on right now, secondary memory stores everything else from files and photos to programs and games. There are three types of secondary storage: magnetic media, optical storage, and solid state storage. Magnetic media refers to storage devices that use magnets to save and access data. Essentially, these devices store information by magnetizing parts of a surface, like a disk or tape. Common examples including hard drives, floppy disks, and magnetic tapes. The data is stored in a tiny magnetic pattern that the device can read and write. While magnetic media isn't as fast as newer technology like solid state drives, it's been widely used for long-term storage because it's cost efficient, effective, and can hold a lot of data. Optical storage. Data on a disk, including CDs, DVDs, and Blu-ray discs, can be read or written using laser technology in an optical storage. In optical storage, a laser inside an optical drive reads pattern of a small pits and flat spots on the disk surface to encode data. Durability, high data storage capacity, and comparatively low cost per unit are the primary benefits of optical storage. Because of its durability and resistance to magnetic interference, it is frequently used for long-term data preservation, as well as media dissemination, such as music and movies. Solid-state storage. Unlike conventional hard drives, HDDs, which stores data mechanically. Solid-state storage stores data electronically using flash memory, solid-state drives. And other solid-state storage systems don't have any moving parts, in contrast to HDDs, which feature rotating disks and moving read-write heads. Faster data access rates, increased dependability, and lower power consumption are just a few advantages of this. How data is represented in a computer system. The basic building blocks of a digital information and binary codes, which are composed of zeros and ones, are used to represent data in computer systems. One of two states, 0 or 1, 0 means off and 1 means on, is represented by each bit. Computers can represent and handle a vast range of data kinds, including text, numbers, graphics, and more by assembling bits into groups. Types of data: binary code, bytes and bits, characters encoding, numeric formats. Binary code: data is represented by a computer using a binary scheme of zeros and ones, or digital processing and storage built on this foundation. Bytes and bits are the smallest unit of data is a bit, which can be either a 0 or 1. A byte, a common unit for storing data in memory, is made up of 8 bits. Character encoding is standards such as ASCII and Unicode are used to encode text data in binary, giving each character, symbol, and letter a distinct binary value. Unicode allows a wide variety of characters from many languages, where ASCII is restricted to 1 to 128 or 256 characters. Numerical formats. There are various encoding formats for representing numbers in binary. Simple binary representation should be used for integers. In signed integers, the sign is often indicated by a single bit. Floating real numbers. To deal with decimals or an extremely large or small values, use more structure. How inscription can be used to represent data. You are explaining the encryption produced. To preserve data privacy, stop unwanted access, encryption is a technique that transforms data into ciphertext. A secure format below is a summary of the essential components. Encryption process. After encryption, decryption key, an individual with a decryption key and the known how to utilize it to unlock the encryption data is known as an authorized user. The sender, the recipient, or anybody else who has been trusted with access to the data can all be considered unauthorized users. How images and sound are represented in a computer system. Images are represented in a computer system. A picture is represented by a grid of pixels, each of which has 3 color channels: RGB, red, green, and blue, each of which represents a distinct binary value with 8 bits, typically allotted to each channel. A large variety of colors are possible. Format like JPEG and PNG, which arrange picture data frequently used. Compression techniques to effectively reduce file size are commonly used in storage image files. Sounds in a computer system. Sound represents as digital audio. It uses a technique called sampling, in which sounds record at regular intervals to transform analog sound waves into a numerical format. After that, a matching bit value is given to each of these samples. The number of samples taken each sound is determined by the sample rate, whereas the bit depth describes the accuracy with which each sample is represented, typically digital audio files and saved in WAV or MP3 formats, which use compression techniques to minimize file size in addition to defining the data's structure. How compression can aid the storage of data, images, or sound. In order to maximize the storage of data, pictures, and music, compression is essential. It makes better use of the storage resources that are accessible by lowering the amount of storage space needed for these digital files. Data compression methods like zip or rar can drastically shrink file sizes without sacrificing the original data's integrity. Images are frequently compressed using formats like PNG, which uses lossless compression to preserve the image's full quality, and JPEG, which uses lossy compression. Similar to this lossy compression methods that lower file size without sacrificing a respectable degree of music quality and advantages for audio files, particularly those in the MP3 and AAC formats. Compression is crucial for effecting data transfers since it speeds up data transfers and saves storage space. The purpose of logic gate. Logic gate, which are essentially components of digital electronic computers, are made to carry out logical operations on binary data. Logic gates provide a single binary output after receiving one or more binary inputs and applying predetermined logical rules. There are essentially for data processing, decision making, and digital circuit control. The following are the main categories of logic gates: AND gate, OR gate, XOR gate. AND gate, only when all of its inputs are true, 1, does AND gate provide a true 1 output. It uses logical and operators, therefore only when all the inputs are 1 will output be 1. The output is 0 otherwise. OR gate, if at least one of its inputs is true, the OR gate generates a true 1 output. When one or more inputs are 1, the output is 1. And when all inputs are 0, it only produces 0. This is logical OR operation. NOT gate, also referred to as inverter, the NOT gate generates the opposite value from single input. The input is false, 0. If the input is true, 1. And the true 1 if the input is false, it's 0. It carries out the logical NOT function. XOR gate, exclusive OR. If an odd number of its inputs are true, the XOR gate generates a true output. When an odd number inputs are 1, the output is 1. According to the logical inclusive OR operation, the output is 0 if both inputs are either 0 or 1. In digital electronics and computer systems, these gates are necessary for construction increasingly intricate digital circuits and carrying out variety of computational operations. The purpose of different types of computer networks. Computer networks connects devices, enable resources sharing, and facilitate communication for a variety of uses. Local area network, or known as LAN, which connects devices to allow the sharing of resources like printers or files, are usually utilized in smaller, more constrained places. Conversely, wide area network WANs are considerably bigger and link numerous LANs over great distance. Whole cities are covered by metropolitan areas. MANs which given give local resident high-speed internet access. Individual users can interact and communicate easily, thanks to a personal network (PN) which links personal mobile devices including smartphones, tablets, and Bluetooth headphones, while client, server, and peer-to-peer models dedicate how data is transmitted between devices within the network. Networks such as Internet and Externet provides various communication structures for business to safely share data among employees or with outside partners. Virtual private networks (VPNs) guarantee safe data access, especially for users who are far away, while wireless networks provide mobility by enabling devices to connect without physical codes. Business may expand and use data storage processing capacity as needed thanks to the scalable resources that the cloud network offers. While social network allows people to communicate globally, industrial networks support the produce employed in production and manufacturing. Lastly, smart gadgets are connected by the Internet of Things IoT network, which supports sectors like automotive industry and offers monitoring services. LANs enables local device connectivity. WANs connect distant locations like cities. MANs cover metropolitan areas. PANs link personal devices. VPN ensures secure remote access. Different kinds of networks have different functions, from facilitating instructional data interchange to enabling local communication and resource sharing. Each network unique purpose determined by a number of variables, including its size, scope, and intent application. Whether a user is located in a single building across a city or globally, these networks are made to accommodate their various needs. The hardware, software, and transmission media used in computer networks. To facilitate communication, computer networks depend on a variety of components. Networks interface cards, NICs, hubs, switches, routers, and modems are examples of hardware that aids in physically connecting and directing data flow. Network protocols, operating systems, security apps, and management tools are essential software components that guarantee safe, efficient communication. Networks use fiber optic, coaxial, and twisted paired cables for wired connections, while wireless connections. The other hand depends on cellular networks and Wi-Fi technology. Together, these elements guarantee dependable, effective information and source movement throughout the network. Hardware, software, and transmission media for communication. Hardware networks interface cards (NIC). Hardware parts that act as a communication interface allows devices to connect to a network. Routers, devices that ensure information reaches its intended destination by forwarding it between server and networks. Switches, equipment in charge of effectively allocating data to particular devices and controlling data flow inside a local network. Software. Network protocols are standards like TCP/IP that provide the guidelines for data transfer and guarantee dependable devices to device connection. Operating system. Devices may connect, exchange sources, and communicate efficiently thanks to the operating system components, which control network operations. Software for network management. Programs and instructions made to keep an eye on, regulate, and maximize network resources for smooth operation. Transmission media. Twisted pair cable, common for Ethernet connection. Coaxial cable used in all the Ethernet network and cable TV. Fiber optic cable offers high-speed data transmission. Identification of a range of World Wide Web technologies. All publicly accessible websites and web pages that people may view on their computers, smartphones, and other devices over the internet are included in the World Wide Web. This digital ecosystem is driven by a range of web technologies that influence our online interactions. The fundamental language for defining the composition, arrangement, and content of web pages in HTML, hypertext markup language. Web browsers, programs like Chrome, Firefox, Safari, and Edge that let users understand view web material. Protocols that make it easier for data to move between web browsers and servers are HTTP and HTTPS. HTTPS encrypts data to guarantee secure connection. These technologies work together to create the Internet's backbone, which makes it possible to access information and digital services with ease. The purpose of different types of computers network topology. Different computers network topologies serve to specify the connection between devices and the data flow inside the network based on variables including cost, performance, scalability, and reliability. Each topology meets particular requirements. The typical kinds of their functions are as follows. Topology of the bus. The globe is provided simple and economical communication between all devices by connecting them to a single central connection, or the bus. Best use case: temporary confusion or small networks where affordability and ease of use are key considerations. Topology of stars. The globe the goal is to link all of the devices to a single hub or switch, making management easy and guaranteeing that a malfunction in one device won't impact the others. Best use case: contemporary networks where dependability and the troubleshooting simplicity are crucial, including those found in homes or offices. Ring topology. The goal is to link devices in a circle so that data can move around the ring in either or both directions. Best uses are networks that need to transmit data regularly, patterns such as some legacy or industrial interrelations. Mass topology. The goal is to ensure high reliability and redundancy by offering several pathways for data between nodes. The best use case is for large-scale fault-tolerant applications or critical systems like telecommunication networks. Tree topology. The goal is to build a hierarchical structure that integrates bus and star topology to enable capable and well-organized data flow. The best use case is for corporate network that needs coordinated connectivity across several levels of departments. Hybrid topology. The goal is to combine aspects of several topologies in order to take advantage of each one's unique advantages for particular applications. Best use case, complex settings that requires efficiency and flexibility such as data centers or huge businesses. Thank you.